Hello, everybody. These are your first set of notes for segment and angle addition. This one is just going to be on the basics, so distance and midpoint and bisecting on a number line. The next couple of videos will get into the segment addition postulate and the angle addition postulate. Okay, so before we start, I want to make sure you know what I normally would show you on slides is on the left side of your screen. What you would write down is on the right side of your screen. I am editing with Cami on my student notes just so that it's easier for me to type and write. But if you would like to edit directly in the document, you can do that as well. Okay, so a couple of things before I get to writing stuff down over here on the right-hand side. I have a couple of important terms that you need to know. Like, really, you just need to be familiar with them. You don't need to memorize them or write them down anywhere. I just want you to know what they are. Okay, you're going to hear me use the term postulate a lot, especially this week. So that is a fancy math word for a statement that we accept as true without having to prove it. So similar to the idea that, like, you don't have to prove to people that 1 + 1 = 2. We just accept that that is the truth. So what it does is it gives us a starting point for proving things that are a little bit more complicated. So this week we're looking at the segment addition postulate and the angle addition postulate. In this video, though, we're going to look more at something called the ruler postulate, which basically talks about how you find distance on a number line. Okay, essentially any point on a line can be matched up with real numbers, like on a number line, and to find the distance between those 2 points, it can be measured with a ruler, and so the distance between the 2 points is the absolute value of the difference between those numbers. Okay, so the way that we talk about distance, the way it is symbolized, is with the 2 points, and now I'm gonna go over to my, here we go. Let me change to a different color. Let's do purple for this one. Why not? So the way that we symbolize distance is with the 2 endpoints. So this would be AB without the line over the top. Remember that the line over the top, this one, that means you're talking about a line segment, not the distance between those 2 points. Okay. Midpoint is another thing that I hope that you've heard, like a term for that before, which is it's literally the middle point. Okay, so it's going to divide your segment into 2 equal lengths. Okay, so here in this drawing that I have on the left side of the screen, this point C in the middle here is the midpoint of line segment AB, meaning that this segment right here, AC, and this segment, CB, are the same length. Okay, and are both half the length of the whole thing, right? So another way that you might hear that described is the point in the middle, point C, bisects that line segment. Bi means 2, and then SECT means to cut, right? So bisect literally means to cut in half, okay? So if we think about this line segment that I have here, if AC is 7, then CB also equals 7, right? If this is 7, then this is also 7, right? And then AB, the whole thing, has to be 14, right? Which I can get by doing 7 plus 7 or 7 times 2, right? The only reason you can do the times 2 is because we're dealing with a middle point. You have those 2 that are exactly the same, okay? All right, so let's look at some actual formulas here. Sorry, let me clear my screen here. So I have the formulas obviously for you on the left side of the screen, but I'm going to switch over to the right side of my screen so that I can write these formulas. Okay, so the definition of distance is that it's the absolute value of the difference between the endpoints. The reason we need the absolute value sign is so that it'll get rid of any negatives, right? Distance cannot be negative, but the coordinate points might be negative, right? On a number line, you can have negative coordinate points. So here, though, distance can't be negative, right? You've never heard of somebody saying, I'm going to go -5 feet in this direction, or I'm going to drive negative 10 miles to school today, right? That doesn't happen. Distance always has to be positive, okay? Because even if you're going in a different direction, right? Like if we're going backwards, for example, you're still traveling a positive distance, okay? So the formula for distance is the absolute value of, let me switch to a text box here, is the absolute value of endpoint 1 minus endpoint 2, okay? And so absolute value of endpoint 1 minus endpoint 2, right? And I will do an example for you with the diagram in a second, okay? A midpoint is the average of two endpoints, okay? So the answer for midpoint can be negative, right? It definitely can be negative because it's a location on the number line. It's not a length, okay? So my formula here, and I'm actually gonna write this one out, okay? My formula here is endpoint 1, which I'm gonna abbreviate with EP, endpoint 1 plus endpoint 2, all divided by 2. Cut it in half. Okay. Okay. Oops, I gotta switch back over here. All right, so here I have the examples drawn for you already on the left, but I'm going to draw them again on the right-hand side of your screen here. So here is a midpoint example, okay? So if I have a number line, and I have point A and point B, right? Point A is at -4 and point B is at 2, okay? It's endpoint 1, which is -4, minus endpoint 2, which is 2, okay? Since these have the same sign, -4 minus 2, right? They have the same sign. You add the numbers and keep the sign, and then I have to get rid of the negative sign at the end, okay? It doesn't matter which point you pick to be point number 1 and which point you pick to be point number 2. I'll show you. So if we did it the other way, and I'll erase this in a second, but if we did it the other way and picked B to be endpoint 1, that would be 2, always minus, and then -4, right? And whenever you have two minus signs right next to each other like this, they become plus signs, right? Basically, the negatives cancel each other out, and you still get absolute value of 6, which is 6, right? So it doesn't matter which point you use, which endpoint you use as 1 and which one you use as 2, as long as you are careful about your negative signs. All right. Okay, so that's a distance example. Same points for A and B here. Sorry, my line's not the straightest here. So I have A and B. A is still at -4. B is still at 2. And I want to figure out where the middle point is right here. That's point C. Right? It's got to be halfway between these two. So there's a couple ways you can think about this. If we know that the distance is 6, then that means the full distance between A and B is 6. You have 3 on this side and 3 on this side. So -4, if I go up 3 spaces, that gives me -1. But here's how you would do it with the formula. You're going to get the same thing. So endpoint 1 plus endpoint 2. So -4 plus 2, because these have, if you're doing this math in your head, right, because these two have different signs in front of them, the 2 has a plus sign, the 4 has a minus sign, you're going to subtract the numbers and keep the sign of the bigger number. So 4 minus 2 is 2, and 4 is the bigger number. It has a negative sign in front of it. So that's -2, and then, whoops, it's very badly drawn here. And then you have to remember to cut it in half at the end. So -2 divided by 2 is -1, okay? And then the very last thing, which I talked about briefly but didn't get into a whole lot, is this idea of a bisector, right? That literally means to divide something in half, okay? Most of the time we talk about these with angles. So it's talking about dividing an angle in half, Okay, so if I have an angle that I'm drawing right here, right, I have this point A, the vertex point, B, third point C. So this is angle ABC. And then if I have another ray in the middle with point D, okay, if D is a bisector, then that means both of these angles right here have to be the same measurement. So I'm just saying, for example, they're both 40 degrees, okay? That's basically it. So I'm gonna end the video here, right? Because these are your notes, and then the next one will have practice problems just for these ideas: distance, midpoint, and bisectors, right? So I will see you all in the next video.